Right. Hey, honors chemistry. So sorry I'm not there, but you'll probably get a couple of remind messages reminding you of what to do. But I wanted to start talking about the first handout and where we last left off yesterday at the end of class, talking about this mass versus volume relationship. So in handout one, you could plot the graph by hand, but we just spent some time in class plotting data. So you might as well use Google Sheets and just share your spreadsheet with me somehow. So I have some selected data here. It's not the same data that's on the handout, but let's say I'm doing question number 1 and I have all of these data points. Your handout looks a little bit differently. You have like 5 data points, but I have all these data points and I want to plot them in Google Sheets. So remember, I have my volume, and I just want to make a note that this volume is in milliliters, and this mass is in grams. Okay, and I also just want to have it centered. Doesn't make a big deal. My y-axis is going to be my mass. So I'm going to make a note that, remember, on the right side is my y-axis, and on the left side, which is my volume, is going to be my x-axis. And that's how we're going to be interpreting this mass versus volume data. Okay, so I'm going to scroll over all of my data. So I click and drag, and then I'm going to click on this little icon that says insert in chart. That's a shortcut for inserting into chart. And it looks like I have one set of data here. And remember, if I want to kind of have XY data, I don't want the column chart. I'm going to change the chart type to scatter plot. Okay, and then notice how it says use row 1 as headers, use column A as labels. That's okay. This graph isn't great yet. I'm going to go over to customize and click on where it says horizontal axis, and it says treat labels as text. You're going to unclick that, meaning you're going to click it and it won't be a checkbox. Now this data looks pretty good. I have that Google Sheets is showing me X versus Y data. If I do this, then this is a mess and it's just plotting only the Y values weirdly. But now I have it as in data. So make sure that this treat labels as text is unclicked. And then I'm going to go over to my series, and I'm going to click on trend line, and it puts in a trend line. And then I'm going to scroll down slightly to label, and I'm going to hit use equation. And as you can see right here, my equation shows up, 2.7x plus 0. And then I'm also going to show my r squared value. So I'm going to go over to series. I think I kind of messed up. And I'm going to go to show r squared. And that r squared is 1. So that is beautiful. Okay, so remember, I have mass on the y-axis and volume on the x-axis. And in your handout, I ask you to write your trendline equation. So I'm going to sample do that trendline equation, just so you know where I'm getting it from. And I want you to put your r squared value in your worksheet. So I'm going to show you what you're doing. Okay, so my trendline equation is coming from right here in the top right-hand corner of my graph. It says 2.7x plus 0. So if you remember, the equation for a line is typically y equals mx plus b. So my trendline equation is going to be equal to y equals 2.7x plus 0. And now I don't have to write plus 0. That's kind of redundant. So I could just say y equals 2.7x. And then if you see my r squared valued, it's gorgeous. So I'm going to write gorgeous. And remember, when my r squared valued is close to 1 or equal to 1, it means that the data shows a linear trend. The data fits within a line. Okay, so this means that my data has a trend that is increasing in linear increments. Okay, and according to that, that's y equals y is equal to 2.7x. Now, later on in the handout, I ask you to kind of interpret this equation, or what does it physically mean? Well, remember, my y values were equal to, my y values were equal to my mass, so mass in grams, and my x values were equal to my volume in milliliters. Mass in grams and my volume in milliliters. Okay, so what does the equation physically mean? For the trendline equation, what does it physically mean? Well, it physically means that my mass in grams is equal to 2.7 times my volume in milliliters. Or you could say grams is equal to 2.7 milliliters. Okay? So what this is saying is that whatever value I have for my grams, if I multiply times 2.7, whatever I have for my volume in milliliters, if I multiply times 2.7, right, whatever volume I have in milliliters, if I multiply by 2.7, I will get my mass in grams. So that is the physical meaning of aluminum. This is where we're talking about aluminum here. That is the physical meaning of aluminum's equation, that if I take my volume and multiply it by 2.7, I'll get my mass in grams. And let me check that. So like I have 25 here, right? Let me see if I do 25 times 2.7, 25, right? It says that on the graph, I should get a mass of 67.5 grams. So let me see, 25, I'll do that right here, 25 times 2.7. And if I do this with a calculator, I get, guess what? I get 67.5 grams. Okay, so I did 25 milliliters times 2.7, and I get 67.5 grams. Okay, now what is the physical meaning of the slope? Okay, so now I want to see what the physical meaning of the slope is. Physical meaning of the slope. Well, in class, we mentioned that a slope is a change in y over a change in x. For us, our y values were mass and our x values were milliliters. So a change in mass over the change in volume, or how mass changes with volume. That is the physical meaning of the slope. And we actually have a specific word for this. How mass changes with volume, we're going to call that density. So the physical meaning of the slope, the physical meaning of the slope is the density in grams per milliliter of the substance. Okay, so this slope is 2.7. That means that the slope is equal to 2.7 grams per milliliter, and that means that the density of aluminum is 2.7 grams per milliliter. So that is going to be big. I would suggest you writing this down somewhere in your notebook, that is what the physical meaning of the slope is. It means that the slope is equal to the density, and that slope is equal to how mass changes with volume. And I could use this slope to change in between mass and volume each time. As I showed up here, like I said, if I take my volume and I multiply it times 2.7, I will get my mass in grams. What if I have a mass? How can I go from a mass to a volume? Well, if I rearrange this equation here, if I take my mass and I divide by 2.7, I should get my volume in milliliters, right? So this is mass equals, this would be volume equals, let me say volume in milliliters should equal my mass divided by 2.7. And let's check that. If I have a mass of 100, let's see if I get like a point on here. Let's see, this one says my mass is 162. If I take my mass and divide by 2.7, I should get my volume of 60. So let's see if I do that. 162 divided by 2.7. If I plug that into a calculator, 162 divided by 2.7, I get 60 milliliters. Okay, so that is how we physically look at and interpret a mass versus volume graph. I will post another video in which we do a lot more of these calculations. But for right now, make sure you're able to plot volume versus mass or mass versus volume. You are able to get the slope from this way of graphing on Google Sheets, and then that you tell me what the physical meaning of the slope is and the physical meaning of the equation. Alrighty, hopefully this was helpful. You may rewind or ask questions if you still need help, and this basically goes along with handout number 1.